everyone, welcome to my YouTube channel. As you all know that myself I am Gangotri. Today I am going to explain the topic of principles of experimentation in design. What is probability? Probability is the likelihood that an event will happen. This can range from an event being impossible to some likelihood to being absolutely certain. In max terms, probability is on a scale from 0 to 1. 0 means the event is impossible, like rolling a 7 on a die that only has digits from 1 to 6. Simple probability is the calculation of an outcome or the chance of an event ever happening. Insurance companies use probability statistics to determine the chances of having to pay out a claim. A simple probability is calculated by dividing a specific outcome by all the possible outcomes. Probability is the likelihood that an event will occur and is calculated by dividing the number of favorable outcomes by the total number of possible outcomes. The simplest example is a coin flip. When you flip a coin, there are only two possible outcomes. The result is either head or tail. Basic terms used in probability. Sample space, the set of all the possible outcomes to occur any trial. Sample point, it is one of the possible results. Experiment or trial, a series of actions where the outcomes are always uncertain. Event, it is a single outcome of an experiment. What is experimentation in probability? An experiment is repeated a fixed number of times and each repetition is known as a trial. Mathematically, a formula for the experimental probability is defined by probability of an event P of E is equals to number of times an event occurred divided by total number of trials. Experimental method refers to the synthetic procedures and steps followed in a research study to conduct experiments, gather data and analyze results. It claims to provide a detailed description that allows other researchers to replicate the study and evaluate its validity. The probability of an event actually happening. A test occurs to determine what is probability of the event is using a specific formula to compare the number of times that event took place and total number of times the experiment was executed. You flip a coin 30 times and record whether you get a head or tail. The experimental probability of obtaining a head is calculated as a fraction of the numbers of recorded heads and total number of tosses. P of head is equals to number of heads divided by 30 tosses. A procedure carried out under the controlled condition in order to discover an unknown effect or law. To test or establish a hypothesis or to illustrate a known law too. The processes of testing. Experimental probability describes how frequently an event actually occurred in an experiment. So, if you tossed a coin 20 times and got heads 8 times, the experimental probability of getting heads would be 8 by 20, which is the same as 2 by 5 or 0.4 or 40%. Experimental design. There are three essential principles of experimental design. They are principle of randomization, principle of replication, and principle of local control. Almost all experiments involves the three basic principles: randomization, replication, and local control. These three principles are in a way complementary to each other in trying to increase the accuracy of the experiment and to provide a valid test of significance, retaining at the same time the distinctive features of their roles in any experiment. Before we actually go into the details of these three principles, it would be useful to understand certain generic terms in the theory experimental design and also understand the nature of variation among the observations in experiment. Randomization. Assigning the treatments or factors to be tested to the experimental units according to definite laws or probability is technically known as randomization. It is the randomization in its strict technical sense that guarantees the elimination of systematic error. It further ensures that whatever error component that still persists in the observations is purely random in nature. This provides a basic for making a valid estimate of random fluctuations, which is so essential in testing of significance of genuine difference. Through randomization, every experimental unit will have the same chance of receiving any treatment. If, for instance, there are 5 clones of eucalyptus to be tried in any 25 plots, randomization ensures that certain clones will not be favored or handicapped by extraneous sources of variation over which the experimenter has no control or over which he chooses not to exercise his control. The processes of randomized allocation may be done in several ways, either by drawing lots of or by drawing number from a page of random numbers, the page itself being selected at random. The method is illustrated in later sections dealing with individual forms of experimental designs. Replication. Replication is the repetition of experiment under identical conditions, but in the context of experimental designs, it refers to the number of distinct experimental units under the same treatment. Replication with randomization will provides a basic for estimating the error variance. In the absence of randomization, any amount of replication may be not lead to the true estimate or error. The greater the number of replications, greater is the precision in the experiment. The number of replications to be included in any experiments depend upon the many factors like the homogeneity of experimental materials, the number of treatments, the degree of precision required, etc. As a rough rule, it may be stated that the number of replications in the design should be provided at least 10 to 15 degrees of freedom of computing the experimental error variance. Local control. Local control means the control of all factors except the ones about which we are investigating. Local control, like replication, is yet another device to reduce or control the variation due to extraneous factors and increase the precision of the experiment. If, for instance, an experimental field is heterogeneous with respect to the soil fertility, then the field can be divided into smaller blocks, such as that the plots within each block tend to be more homogeneous. This kind of homogeneity of plots experiment units ensure an unbiased comparison of treatment means, as otherwise it would be difficult to attribute the mean difference between two treatments solely to differences between treatment when the plot differences also persist. This type of local control to achieve homogeneity of experimental units will not only increase the accuracy of the experiment but also helps in arriving at valid conclusions. In short, it may be mentioned that while randomization is the method of eliminating a systematic error in allocation, thereby leaving only random error component of variation, the other as follow as possible. All three, however, are essential for making a valid estimate of error variance and to provide a valid test of significance. Thank you.